Good afternoon, sir. My name is Lim Siu Song. I am from Department of Computer Science at Paragon International University. Today, I'm going to present you a topic called Lies My Computer Told Me. Here is the table of contents that I will going to represent you today. The first one, Lies My Computer Told Me. Second one, pressure privating. Third one, counting operation and introduction to the analysis of algorithm. First one, lies my computer told me. Part one, computer and calculator store real number, for example, 5.2, 3.44, and pi. And also an exponential is also an example in here. Calculator store around 8 to 12 digits, while computer can store more digits, but not infinity. The number of digits the computer or calculator can hold are called significant digits. This can lead to run-off error because some digits are missing. Because of capacity of the calculator, that means missing digit can sometimes lead to a huge error during the answer. That's all. Let's take a look at an example. X plus y is equal to 0 and x plus 1.00125y is equal to 1. First, we apply O2 minus O1. We will get that 0.00125y is equal to 1. Third, y is equal to 800, and then substitute y to the first equation. We will get x equal to minus 800. Let's look at another example, but this is the same example. This time we only use 5 significant digits. The last 5 is missing from the equation. We do the same operation and we see that y is equal to 833.33. Substitute y to the first equation. You will get x equal to negative 833.33. This shows that a single missing digit can lead to a huge difference. Now this time we only use 4 significant digits. We do the same calculation and see that y is equal to 1000 and x is equal to negative 1000. As the run, we do more runoff error as the digit is missing. As you can see, if you only use 3 significant digits, this system doesn't have a solution because as x minus x and y minus y, we will get 0, and the last part we will get 0 minus 1. Is 0, it's not equal to 1. This type of system that is sensitive to runoff error is called ill-conditioned system. The second part, pressure privating. First, let's try to solve the following equation. 0.00021x is equal to 1. Third, x is equal to 4161.9. Now, what if we only use 4 significant digits to solve, which we will get 0.002x is equal to 1. Third, x is equal to 5000. As you can see, there is a huge difference, about 300 value in this answer. Now, let's try to solve this with a system of linear equation. First, we apply 1 over 0.401, which we will get x plus 249 is equal to 250, and the second equation remains the same, and we apply our O2 minus 25.301. You will see that O1 will get 35.3x plus 18,749.7. Y is equal to 18,825. But remember, we only use 4 significant digits, so the remainder we will get 725.3x plus 18,800 700y, and the second part also round off to get 18,800. Next, we will get 0 minus 18,745.3 is equal to 18,770. Again, we only use 3 significant. We will do the round off and get 0, which then solve for y. See that y is equal to about 1.01. And then substitute y to the first equation. We will get x is equal to -1. Now let's solve the system with only 3 significant digits. We do the same operation, interchange x and y, R1 over 75.3. All 1 we will get 9, x minus 0.1602y equal to 0.398. Next, we will use our 2 minus 0.4 or 1, which is equal to 0.4x plus 18.12y is equal to 12. But we only use 3 significant digits, so we will get 18.1y. Then the second equation, we will get 99.8y is equal to 99.8. Third y is equal to 1. Substitute y into the first equation, we will get x is equal to 1. This is a huge error because the last time we see that y is equal to 1 and x is equal to -1. So there is a huge difference between this. Now let's talk about some rule for partial privating. The best solution is first to find the largest absolute value in the first column, which is A, E, I, and If then move the row to the first row, for example, if A is the largest absolute value, it stays there the same. But if I want to be an absolute largest value, we move I to which is a row interchange. Next, we use elementary row operation to make the 0 in the first column, except the first row, which we already move the largest to the top. And the remaining 3 is 0. Use the same method for the remaining. Now, until you get a row echelon form, meaning that we can see that this is another matrix system and we can do the same. For example, F, J, and N, we will find the largest absolute value and move that up and do a row in the chain and make a 0 as before. And we keep doing this until we get a row echelon form, and then we do a substitute to find the answer. Third part, counting operation and introduction to the analysis of algorithm. Part 3, counting operation and introduction to the analysis of algorithm. What is algorithm? Algorithm is a procedure that requires multiple steps to complete a specific task. There are some tasks that have 2 or more algorithms because different algorithms require different steps and ways to solve the same problem. Means that one algorithm is more efficient than the other. So we will use Gaussian and Gauss-Jordan elimination as also an example of the algorithm. Solve the system using Gaussian elimination and count the total operation, multiplication, and divisions. First, we take all 1 times 1 and divide by 2. So we take this one, 1 times 4 divided by 2. We don't do the multiplication or division on the first column on the first row because that is a pivot. So we do from the second row, second column of the first row is 4. 4 times 1 is equal to 4 and then divided by 2, so it means 2. And we take 6 times 1 divided by 2 or so, and we take the fourth column of the first row. It means 8. 8 times 1 divided by 2. So in this line, we have 3 operations. And the next one, we use all 2 minus 3 all 1. we take 3 times 2 plus 3 because we don't take the first column 1 because it is a pivot. We take from the second column of the first row. We take 3 times 2 plus 3 times 3, and the first column 1 on the first row is 4 times 3. So this means this line has 3 operations. So the next operation will take all 3 plus all 1. So the first one we don't do it because it is a pivot. The first column of the first row is a pivot. So we start doing from the second column of the second column of the first row. 1 times 2 and 3 times 1 and 4 times 1 equal to 3 operation in this line. And next step we will use all 2 times 1 and divide by 3. We this time there are only 2 operations because the first column of the second row is 0. We don't do it. And the second column of the second row is a pivot, so we also don't do it. We only do the third column and fourth column of the second row, which means minus 3 and 0. We take that times 1 divided by 3. So in this line, there are only 2 operations. Next one, we take all 3 minus 3 or 2. So we don't take the first column because that is 0, and we don't take the second column of the second row because that is a pivot, and we take only the third column of the second row, which is minus 1. So we take 3 minus times minus 1 and 3 times 0. So this line has 2 operations. And the last step one, we take all 3 times 1 divided by 5. We don't take the first and second column of the third row because that one, the first column is 0 and the second column is also 0. We take only the fourth column, and the third column we also don't take it because it is a pivot. The fourth column, 5 times 1 divided by 5 is equal to 1. So in this Gaussian elimination, there are 14 operations in this. Next, we use Gauss-Jordan eliminations to find the total operations. The first one we take O1 minus 2 O2. So we take minus 1 because the first column and the first column of the second row is 0, and the second column of the second row is a pivot. We take only minus 1 and 0. So this line have 2 operations. Now we take all 1 minus 5 or 3. We don't take this step also 1 operation because the first and second column of the third row is 0, and the third column of the third row is a pivot. We only take the first column of the third row, which is 5 times 1 equal. So it means that is equal to 1. Next, we will take all 2 plus all 3. There also only 1 operation because other column is 0 and the pivot. In this step, there are 18 operations. So to sum up, using Gaussian elimination is more efficient than using Gauss-Jordan elimination because using Gauss-Jordan elimination, we have to do more steps than Gauss elimination. So this is all of my presentation. Thank you, teacher, for your time to watch my presentation.